Take a close look at this machine. What may appear to be a simple engine from the outside is actually a highly engineered system designed to convert fuel into useful mechanical power. This cutaway model allows us to see inside the engine and understand how its various components work together to produce motion. At the heart of the engine is the cylinder, which contains the piston. The piston is one of the most important components because it moves up and down inside the cylinder during operation. This movement is responsible for creating the power that eventually drives machinery, generators, pumps, and many other types of equipment. The operation begins with the intake stroke. During this stage, the piston moves downward inside the cylinder. As it travels down, fresh air is drawn into the combustion chamber through the intake system. Unlike gasoline engines, diesel engines generally compress only air during this stage. Next comes the compression stroke. The intake valve closes, and the piston starts moving upward. As the piston rises, it compresses the air trapped inside the cylinder into a much smaller space. This compression dramatically increases both the pressure and temperature of the air. In diesel engines, the compression ratio is much higher than in gasoline engines, which is one of the reasons they are known for their efficiency and power. As the piston reaches the top of the cylinder, fuel is injected directly into the hot compressed air through the fuel injector. The injector delivers a precise amount of fuel at exactly the right moment. Because the air temperature has become extremely high due to compression, the fuel ignites automatically without requiring a spark plug. The rapid combustion creates a powerful expansion of gases inside the cylinder. This expansion forces the piston downward with tremendous force. This stage is called the power stroke because it is the only stroke that actually generates useful mechanical energy. The downward movement of the piston is transferred to the connecting rod, which then rotates the crankshaft. A crankshaft is located in the lower section of the engine. Its primary purpose is to convert the piston's up and down motion into rotational motion. This rotating movement can then be used to drive equipment, generate electricity, power vehicles, or operate industrial machinery. After the power stroke is completed, the engine must remove the burnt gases from the cylinder. This happens during the exhaust stroke. The exhaust valve opens, and the piston moves upward once again. As it rises, it pushes the spent combustion gases out of the cylinder and into the exhaust system. Once the gases are expelled, the cycle begins again. Another important feature visible in this cutaway model is the gear system. These timing gears ensure that the valves and fuel injection system operate in perfect synchronization with the movement of the piston and crankshaft. Even a small timing error could reduce performance or prevent the engine from running properly. The large flywheel attached to the engine helps maintain smooth operation. Because power is only produced during one stroke of the cycle, the flywheel stores rotational energy and helps keep the crankshaft turning evenly throughout the remaining strokes. Diesel engines are widely respected for their durability, fuel efficiency, and ability to generate high torque. These characteristics make them ideal for heavy-duty applications such as tractors, construction equipment, generators, ships, agricultural machinery, and industrial systems. What makes this engine truly remarkable is the precision with which every component works together. The piston, cylinder, valves, injector, gears, crankshaft, and flywheel all perform specific tasks while operating in perfect harmony. Thousands of combustion cycles can occur every minute, each producing power and contributing to the overall performance of the machine. This cutaway model gives us a unique opportunity to observe the inner workings of a diesel engine and appreciate the engineering principles that allow fuel, air, pressure, and motion to combine into a reliable source of power used throughout the world every day.